Well, hi, and thank you for joining me in my shop today. I'm returning to work more on this Sony 2001 radio. I've put a couple hours into it. It's a kind of circuitry I'm not that familiar with, so this is quite a cold journey for me. I'm really poking around in the dark in the previous videos, just hoping to encounter something that might reveal something to me and give me a hint as to where the problem might lie. And luckily I've been getting some excellent advice from well, perhaps from you, if you are Time Spider or my Ham Shack. If that's you watching this, thanks a lot for the help you've given me and the encouragement. Both of you are pointing out the same thing. In the last video, you're pointing out the same thing. Basically, on a general basis, my approach is bad. I should really be going after the voltage regulators and power supply issues, same as any device. And I'm not. I'm just out, walking around the farm, poking here and there. So I'm gonna take the direction you guys are suggesting and try to figure out what's going on with these regulators. I guess especially this 18 volt, 14 volt regulator, which I discovered to be a little bit warm. If I remember right, last time I was working on this. So I've also been told, can you see those? Fairly detailed comments I've gotten from you guys. That the actual regulator is probably buried below boards, or it's underneath, or somehow it's inaccessible from the top here, the actual regulator. And there's more than one of them. There's a few others cast out through the radio circuitry. But I believe the one we're really after is right in this area here. So, now, I've got the board layouts here. It's challenging enough for me to even just recognize which board is which. So, and also, what am I looking at? The underside or the top side? Looks to me like this would be this board flipped over. So I think I'm looking at the underside here. And it's curious how they've colored the traces here, and I'm sure there's a reason for that, but I don't know what it is. Maybe all these gray ones are ground potential. They look like it. They're very large traces, so maybe all the gray is ground and the red is not ground. And that's how that works. Oh, I got the same page twice here. What good is that? Oh, I have two eyeballs. Maybe I made one for each eyeball or something. I think I have some more documentation around. I'm going to have to hunt it down. So, now, let's see. The hint here is that the regulator transistor is in the 5 o'clock position from the speaker hole, which is probably underneath other boards, making it hard to access. Okay, so 5 o'clock puts it down in this area. Oh my gosh, I wasn't looking anywhere down there. I've been looking up in this area here and across the top, if I remember right, and looking under under here a little bit. Now you might be wondering, well, so why would a regulator be the part that would be of suspicion? And I think the answer is the regulator it works hard. It is constantly dropping current to control the voltage, and I'm going to guess it just runs a little hot and it works fairly hard, and that's why it becomes a problem down the road. Many other parts in a radio like this are generating no heat. There's nothing. There's just not enough electricity flowing through them to heat them up at all. So they can sit there quite happily, on or off, they don't care. A few other parts, though, do get heated up in the process of their operation, and those parts suffer mechanical problems, and the heat itself could cause some kind of chemical changes in the materials involved, and over a long period of time you can get some kind of failure. So it is really all about heat. This is not complicated from that point of view. Heat, mechanical motion, these are the things that kill radios. And also moisture. Moisture getting into them. So, okay. So we really got to find this regulator. I got to find my more detailed circuit diagram. Boy, oh boy, I wonder what I did with it. 'Cause it's been, how long has it been? It's been about a month since I worked on this radio. So, okay, I got to go hunt down some more paperwork here before we really. Okay, well, it took me a little while. I had to print a new circuit diagram and prepare the pages, tape them together, and make one great big circuit diagram here. Lucky for me, I don't have to understand all this stuff. Man alive, that's a career in itself. I think what I got to focus on, and I think what a couple of you guys are suggesting, is really in this power supply area here. And I seem to remember a comment about the timer, which I didn't understand what it was, but now I see there's a external timer plug here. Come on, little camera, you can focus, can't you? There we go, sort of. And this seems to be connected to the power switch here. Not exactly sure what's going on with this, but it looks like you put on an external timer, or this will drive an external timer. I'm really not sure what this is all about, but nevertheless we should work that plug a couple of times. There's the on-off switch right there. Right away, a couple of transistors, some voltages for me to read, and there's that DC to DC converter. It jacks the voltage up from 4.4 coming in from the batteries, and the output looks like 6.2. Oh, there's the 18. Yeah, there is an 18 volt bus coming out of it too, or an 18 volt supply. There's a Zener here, Zener diode there. So I imagine this is all about voltage control through here, I think. That's my thinking, so that's what we're going to poke around with. So I think my first task here is to locate some of these critical parts on the circuit diagram here on the actual circuit. And I have a pretty good notion where a lot of them are, because here's where the power cord goes in, and you've got to imagine all these power components are going to be right here. And of course here they are. Big large capacitors, this converter, and this unusual looking component here. Looks like a SCR. Not sure what it is. I don't think it's an SCR, but it looks like one. So maybe that's the regulator right there. So let's explore this area. Now I don't think I lifted this lower board out at all. No, everything is still in place. I haven't loosened any of these boards. And let's give you a ringside seat on this process. I think I can do that. There we are. I think I'm going to turn off the autofocus on the camera too, because it tends to have a bit of a mind of its own. There we go. So now, let's get out my diagrams here. This is really on the fringe of my knowledge and experience, for sure. Okay, so this guy here, and I'm looking at this diagram. Oh, you're not. Camera's down here now. Can't really show you. I'm looking at the board diagram, and it shows this as just being a transformer. No, wait a minute. Am I looking at this right? No, I'm not looking at this right. There's the transformer right up here. There's actually a transformer sitting right here. I can see it. This is upside down and all around. So this is the DC to DC converter. I've now kind of figured out how I should look at this. This is from underneath, for sure, because they're showing the parts up on top, like these parts, using dotted lines. So that usually means you can't see the thing. So I can certainly see it looking from the top. So this must be shown from the bottom. Good thing I'm figuring out which end is up, eh? That's kind of what I'm doing here. And there's the values written right on this sheet. I should go looking for them. But they're shown on the underside of the board, for crying out loud. There's a few here. I think there's a few here I can test. And there's the timer again, output. Let's poke around with some of this stuff. First, I gotta get this thing plugged in and making some kind of sound. So let's plug in the power supply. I can't even remember what it sounded like before. What did it sound like? Make a little hiss. I think it did make a little hiss. Okay, let's switch on. Now, how do we know it's even on? Pretty hard to tell when it's not working. Oh, I hear a hiss. Okay, so there's a radio hiss coming out of the speaker. Very faint. It's affected by the volume control. So let's get out the voltmeter and we'll take a look. Now, I know what I realized about doing close-ups on video is you stop seeing all the motions around. Your field of view is very, very small, so you don't see a lot unless something comes right into the field of view. So much of the time you're looking at a static picture, just listening to my voice. Kind of makes for boring television, doesn't it? Now these voltages must be referenced to ground, and let's see, I might be able to pick ground off these bigger capacitors. Like this one's got a real exposed point on it. 1000. There's two 1000s right in here. This has got to be them right here. There's 1000. That's got to be 1000. So I'll bet you that's an excellent ground point, which you can't quite see. And I'm going to clip onto it, because it's actually big enough to get a clip in there. I think it's big enough. Okay, so I got a clip on the negative lead of that capacitor. I'll clip that on my meter. I'll have to just tell you what I'm reading on the meter because you're close up here right now. And first we're going to try to find the 4.5 volts coming in to the set. And where would I find that? Find that on transistor Q27. This is Q27 right here. And I'll betcha this one is Q26. I bet you right there. So looking at Q27, the leads are fairly accessible. We should be seeing things like 4.5 volts. Okay, so on that meter I am seeing 5.6. That's probably simply what's coming in from the little power supply, which is supposed to be putting in 4.5, but it's actually putting in 5.7. So on the base of this transistor, we should be seeing 3.7 volts. Let's see if I can get in there. Ooh, a little noise on the speaker. We got 5.6, 5.6 on there, 5.6 on that lead. Bend that guy a little bit. Get on the other lead. 4.9. Where it should be 4.4, I imagine. Now wait a minute, this might, no, you know what? So let's read the actual voltage coming into this thing. Holy crap, how am I going to do that? Maybe right there. Oh, so that's what's coming in? 4.1? 4.1, 4.2 volts? 4.2. Let's see if it jumps up when I shut the set off. Doesn't do much of anything. Doesn't go away anyway, so I'm pretty sure that's the voltage being supplied by the little power supply. It's a little low, eh? But then again, this thing should be able to run with batteries that are going weak too. So it shouldn't hurt to be a little low. 4.1, it's supposed to be 4.5. Okay, so anyway, that voltage, the 4.1, should show up. Should probably show up right here. And I got 4.9, 5.6, and 5.6. And they're really supposed to be 4.5 going in, 4.4 coming out. So I'm trying to drop just a tiny amount. Okay, let's look at the other side of the DC to DC converter. There should be 18 volts, and that should show up on Q33. And you know, I'd say collector or emitter, but frankly I'm always getting these confused. On a pin that's not the base, let's put it that way. Now where would that be? Q33 could be anywhere, for crying out loud. How am I going to find Q33? Q33. So I'll look at this diagram and see if I can spot it quickly. Holy smokes. Q33. Hopefully it's right in the area. Yeah. Q26. Q9, Q12. Oh yeah. Okay, so that's not showing up easy. It's not in the area of the power supply. Wherever that transistor is, it's somewhere else. Oh yeah, so we were going to check this jack, this timer jack. I guess we test it by just plugging something in and out of it a few times. Okay, timer jack. Yeah. So we've got DC in. The next one is a timer. So this is the timer jack right here. No obvious change in the radio's operation. Nothing changed there, I don't think. Reading the same output voltages. Or input voltages, really, that's what we're reading. Okay, and last thing we were doing there was searching for the 18 volts. Well, there is a wire up here that should show us 4.5 volts. It shows us the 4.1. Now this is right off the supply. So I'm going to raise the supply voltage here. Okay. You know, these little power supplies, little variable power supplies, the speaker's a little louder. Well, it still reads 4.1 exactly. Well, how's that happen? Let's read the voltage rate on this. Well, I'll be. I just pulled out the power supply plug. The radio continued working. Of course, the batteries are in. Okay, this is supposedly bringing in 8 volts. Almost 9 volts on this thing. Let me turn it back down because that's a little uncomfortably high. Okay, so now my little external power supply is set to 4.5 and it's actually producing 7 volts. As I plug this in and out, makes no difference in the radio. They wiggle it around. There's a lot of static and noise. Well, not a lot, but there's some. So, yeah, I wonder if this power is getting anywhere into the radio at all. Let me just check my ground point here that I've picked. Shouldn't be any problem with reading. Shouldn't be any problem with reading at 4.5 volts. At 4.1. 4.1. That's probably what these batteries are supplying. 4.1. Let's see. Just read the batteries here. 4.1. So batteries are a little low, but that's what's getting through. So the power supply voltage, being supplied from the outlet here, is just not making it into this radio at all. That's curious. Well, I think that's a hint of something. Let's pull the batteries out of this radio. I'm going for a bit of a ride here. Okay, batteries are out. 3 D cells. Radio's still making the hiss. Didn't hear any change in its operation. What the heck is going on? I'm going to read the voltage here now, which should show up. It really should show up as the voltage of the power supply. That's interesting. The speaker is still making a hiss, and okay, I pull the power out and the hiss goes away. So okay, so the voltage that I'm getting out here is 5.7. 5.7 right there. 5.7 exactly the same there. 4.9 here. And what is the input voltage? So there's the capacitor and ground connection that I've made. And let me just double check now. I don't think it matters which of the thousands. Oh, maybe it does. Now this one is very close to the power coming in, and the other capacitor is located a little further away. This is probably the right capacitor. So if I'm on the ground of that capacitor, I'm grounded here. I'm looking at the circuit diagram. Slightly separate from the rest of the radio. How come? The ground goes through the timer switch. This must have been what was being suggested to me. I need to watch out for this timer switch, because if it doesn't close properly, the whole radio won't work. And that's pretty interesting. But I think I've proven the timer switch to work, and part of the reason is... Wait a minute. Part of the reason is the way I read the voltage. I seem to have made a reading which is beyond this timer switch problem. But you know what? Maybe not. Let's look and see if I can get... let me back you up a little bit here. In fact, how about this? How about this? My camera is fairly flexible, you know. I get to kind of mount it in all kinds of different ways, but it still has its limits. Okay. So here's the capacitor I'm using to find the ground. There's the ground clip right here on it. But now I want to try to read the voltage on this other capacitor here. You hear a little click in the speaker when I was doing this. There we are, 5.6. So everything is reading 5.6 when it really should be, I think, 4.4. I'm getting, on this component here, I'm reading the same voltage on 2 pins of 3. And I don't think that's normal for a capacitor, or for a transistor. Usually you're getting 3 different readings on each pin. To get the same reading on 2 pins, you know, that's screaming short circuit. Short circuit in that transistor. Now, or it's this other one here. This other guy. Let's see. Okay, we're getting 4.1 on there. I'm not sure what lead I'm touching either. Oh, it's really tight in there. I don't think I can... get a... 5.1 I'm reading there. I think that was the base of it. Oh, it's supposed to be 0. What? 0 volts. No, I may have been down on the collector or emitter, whichever one it is. So I probably didn't get the base there. I can't really see under here either. Now that's really interesting. I just touched something. The speaker got louder. You can hear the speaker going too. And I'm looking up at the display to see if the display is coming on. The answer is no, the display is not coming on. Turn off the radio and turn it back on here. You know what? I think I saw some display there. Did I? Very awkward doing this. Sorry, I just saw the hey! Signal strength light came on. But no display yet. Oh, that's interesting. I imagine what I'm doing with this voltmeter lead, which you really can't see anything anymore, is I'm just shorting out a couple leads in that transistor. I'm pretty sure that's what I'm doing. Well, I'm all tangled up here. Wait a minute. Yeah. Well, doesn't want to hang there anymore. Okay, go sit over here. Curious about why I can't see the actual voltage coming in from the power supply, unless that voltage is actually falling because of the load of the radio and I'm just being fooled. Maybe it really is 4.1. That voltage should appear on the positive side of the capacitor. Should see the input voltage here. Oh yeah, I got 5.6 volts, and that does sound like the input voltage, doesn't it? So we got 5.6 across this capacitor. It's supposed to be 6.3. Let's boost up the power supply here again, as much as I don't like doing that. Okay. So we've raised it now to 6 volts on the input. Setting is 6 volt. The actual reading is 7.5. Pretty high. Curious, I touch any part with my meter and the speaker hiss increases. I doubt you can hear it. I'm listening to it very carefully now. Well, there's some kind of chuffing going on in there. In the hiss. So that suggests, you know, some of the digital components of the radio are working. Oh my. Well, these voltages are just all wrong here. Oh, there's another 1,000. No, that's the same one I was looking at. So I think it's this one here. And that guy... Again, I just contact the positive side of this capacitor and the radio makes more hiss. 7.3. 7.4 is what I'm reading there. That's the input voltage, isn't it? Well, maybe I got this all wrong. These capacitors are actually in reverse of what I thought they were. And they're grounded differently. So I'm really not reading properly across this capacitor, I think. Let's see if I can get right on both leads here. Seven point four volts is what I'm reading across that capacitor. 7.4. And this other one, other capacitor here, I am reading 7.42. It really looks like all these components right in the power supply here are messed up. But I'm not so sure what to do about them here. I'm still pumping in that high voltage. Let's switch it back to a more appropriate range. And. So I would say the DC to DC converter is not getting the voltage it needs. Now, how true is that? C80, there's a number for that. Hey, I can figure out which capacitor is which based on the number. Let's see. Number... No, that's easier said than done. There we are. There's C80. Okay, so this is C80. This guy's C80, and C80 is the second capacitor farther into the set from the power supply. So that makes this one C164, and on it is nothing but the power supply. So it's kind of like a filter for the power supply coming in, because often these cheap little wall power supplies are pretty noisy. So you got a filter there. Which we expect to see 6.3 volts on it? Well, how would that be? Why wouldn't you just see the 4.5 input voltage on that capacitor? Because that is what we see. We just see the input voltage. Oh, is that the capacitor rating? No, it is. That's the capacitor rating. That's not the voltage. It's just the rating, for crying out loud. So the voltage should be 4.5 volts. Okay, settle that down. We should see 4.5 volts across this capacitor. And what we actually see is, I see nothing at the moment. What happened? Here, my negative clip lead came off here. Oh boy. Sit there, please. Here we go. 5.6, which is the supply voltage. 5.6. Then on the other side of Q27 we should find 5.6 on one side and 4.4 on the other. Of Q27. Okay, so this is Q27. I can see it written right on the board. One side of it should show us the same reading we just got, 5.6. There it is. The other side of it should show us 4.4. The other 4.8. Hey, that's pretty good. And then in the middle, assuming that's the base, we should be seeing something like 3.7. But I see 5.6 there. See, I may have the terminals incorrect on this component. I may not. Is it marked somewhere? Would it be marked? Oh, it kind of is. It kind of is marked. The base. Base is not in the middle. You should see 3 point. Now let me get this right because this is upside down, turned around. But the order should be correct. So on this pin I'm going to test, we should see 3.7 volts. Now let me back it up. The first pin I'm going to test, we should see the supply voltage. The full supply voltage. Right, test the pin and we get 5.6 full supply voltage. That's now on the center pin, which is the collector emitter. I don't know which one of the two. The center pin, we should see 4.4. On the center pin we see 5.6. So I think there you are, right there. I'm getting into trouble. And then the base, driving it, 3.7, and the base is out here. See, the base voltage is 4.8, so that's not correct. So what's controlling the base voltage on that guy? What controls the base voltage on here? Join me for this here. Yikes, I'm all tangled up. Okay, so here's what I'm looking at. There's the DC to DC. There's the two transistors. Here's the input where the power supply, little power supply plugs in. So this 4.5 number here is the assumed voltage coming in from the DC supply. It's not actually 4.5. In my case, it's 5.6. So 5.6 reads there. I can read 5.6 here. Here I read 4.4 or something like that. Let me check it again. I read 5.6, full voltage here. So that voltage is being controlled by this transistor here. Okay, so this transistor here, Q26. Q26. Just trying to spot it on this picture here. So Q20 there. That says 45. Q45. Q27, Q45. Q27, Q26. What am I reading? Can you read that in there? Q45. Q27. Q26. There it is down there. Okay, so we'll Q26. They're not that far apart on this board. Q26 is down near this big, so that must be it over there, right out by the edge of the board. Q26, kind of in this bendy loopy area, and it's between. This is really hard because this is upside down and backwards. That's why I'm having trouble relating this stuff. Sorry about the camera work there. Once again, let's just run this through again. So it's located between, if you drew a line from Q27 up this way, tucked into the corner, there it is, there it is, there it is. Okay, so here's the one transistor, here's the other one up here. And I thought it was this one here. This guy here, just because of his location, but it's actually this one up here. You can see Q26, I can see it in there, Q26. So let's test that guy now. Sorry about all the camera work here, but I'm looking elsewhere when I'm looking at the, well, here, you look at it with me. Okay, so where'd it go? Q26. So we see it goes from the speaker hole, it goes base, collector emitter, collector emitter. The base should be 0 volts. So let's go look at that. That's a pretty good, here we go. And of course my meter's gone to sleep. I got a meter that times out no matter what. Hang on, I gotta fix a couple of leads here. You're right in the middle of taking a reading, it just times out and goes to sleep. What a crazy meter that is. It only stays awake for about 5 minutes, I think. Something like that. Okay, we're ready for that measurement now. Right down in here. I'm on there and 0 volts. Okay, I go on the center pin. 0 volts. I go on the top pin. How does that work? 0 volts on all pins. Zero volts on all pins. 0 volts on all pins. Switch not on. Because the switch is actually driving this. Okay, let's switch off and see what we get here. Okay, so I'm back on this guy. The switch is off now on the radio. Get 7 there. Almost 0 there. 7 there. So I get 7 on the 2 outside pins, which is the input voltage, I'm sure. Right here. Get 7 volts on the base. 0 in the middle. I don't know. That's not gonna. I don't think I'm gonna be able to sort that out, frankly. Well, there's some more interesting information. I think I'm gonna post this video and get some guidance from those who know better than me. In fact, some of you guys appear to have direct experience with this radio, so that's fantastic. You know, I'm just out of my comfort zone. That's my problem here. But I think the problem does lie right in this area, and maybe with the experience of others, I can get another good hint on where to go, because this definitely seems to be a problem area in the radio. So thanks a lot for watching, and we'll see you on the next video.